So in the first part of the video, in part 1, we looked at the x and the y of all the principal angles related to 30, 45, and 60 degrees. So now we're going to open it up and look at trigonometric ratios, not just sine and cos, but tan, cosecant, secant, and cotant. So let's actually use 210 as an example. So the first thing you need to do is ask yourself, is 210 related to 30, 45, or 60? And how are we going to do that? So we're going to graph the terminal arm of 210, and based on this we know that the axes are the following, and we know that 210 is somewhere over here. So I'm going to draw the terminal arm and we'll call it 210. So that's in quadrant 3, and the next thing we're going to do is figure out the RAA, the related acute angle. Remember, related acute angle is the angle between the terminal arm, which is this piece here, and the x-axis of that quadrant. So we're going to figure out alpha. So let's figure this out. So we know already established from here to here is already 210. And we know that this piece here is supplementary, meaning it's worth 180. So we need to get this extra piece, this alpha RAA is going to be 210 minus the 180 will give us 30 degrees. So in this case, this is 30 degrees. So now we're going to have to figure out the x and y coordinates of here, over here at the end of the terminal arm. So going back to the 5 special numbers, 0, 1/2, root 2 over 2, and root 3 over 2, and 1. We know it's not going to be the middle one because the middle one is 45. 45 is the middle number between 30 and 60. So we know it's going to be either 1/2 related to 1/2 or root 3 over 2. So let's look at their diagram. So the way that I'm drawing this may not be to scale. So the question right now is, we know that this x and this y, they're not the same because they're not isosceles. But one of them is shorter, one of them is longer. So how are you going to know which is longer and shorter? And we use the angles. So in this triangle here, we know that this is 90, this is 60. And to know which side is longer or bigger, the opposite side with the larger angle is going to be the larger side. So 60 is larger than 30, so I know that this side is going to be bigger and this side is going to be smaller because 30 is smaller than this. So I know based on these two numbers, the smaller number is going to be over here, 1 over 2, and x will be the bigger number, which is root 3 over 2. So I know my coordinate is going to be x, which is root 3 over 2 and 1 over 2, but we need to adjust the signs because this is in quadrant 3. We know that this is going to be negative, and the x is in this way is also going to be negative. So we know that this is going to be negative root 3 and negative 1 over 2. So now we can actually go to figure out the trig ratios. Now, remember what sine means? Sine is the y value, cos is the x value. And in this case, our y value for this piece here is negative 1 over 2. Our x value is going to be negative root 3 over 2. And we know that cosecant, 210, is going to be the reciprocal, which is negative 2 over 1. Meaning we're going to flip, and this is going to be negative 2 over root 3. Now, tan. Tan, we mentioned before, is opposite over adjacent, or we can call it y over x. In this case, we're going to take the y, which is negative 1 over 2, divided by x, which is negative 3 over 2. We do some division, and we know negative gives you a positive, and that gives me 1 over root 3 at the end. I'm not going to show all the details of division. Cotant and tan, they are reciprocals, so instead of y over x, it's x over y. We can do the same thing here, but at the end, we're going to actually get the reciprocal, which is root 3 over 1, which is the same thing as root 3. So now we're going to move out of the unit circle and go to a circle that doesn't have a radius of 1. So determine the xy coordinates on a circle with a radius of 5, where the principal angle is 240. So we have two ways to do this. We have the coordinate equation. So remember that xy refers to cos theta and sine theta, but this is for a unit circle. So we're going to open it up to a non-unit circle where we're going to have to multiply by the radius. So in our case, the xy, the point on this circle, is going to be, radius is 5 cos, and the principal angle is 240 degrees, and this 5 is going to be sine 240 degrees. Now the next hurdle is trying to figure out these two numbers. So to figure out 240 degrees, I'm going to draw 240 degrees, which I know is between 270 and 180, and it's going to be somewhere like here, all right? And then I'm going to figure out the alpha, which is the related acute angle, by doing the same methods that we did before. I end up getting 60 degrees. So I know my 60 degree looks like this, where the x seems to be smaller than the y based on my diagram. And in this case, I know that out of the two numbers here, 1/2, I always go back to these two numbers, these 5 numbers, sorry. I know that I'm going to be using the 30/60 related numbers, ratios, and I know that this one here is going to be negative 1/2 because it is in the negative side, it is shorter, and in this one here is going to be negative root 3 over 2. So I know that cos 240 is the x value, so I'm going to go back to my diagram here and look at the x value, which is negative 1 over 2, and the other one's going to be the y value, which is negative root 3 over 2, and all I'm going to do is just multiply the fractions, so negative 5 over 2. Remember, when you multiply fractions, numerator, denominator, this is going to be negative 5 root 3 all over 2. So this here is my coordinate. So the other method is to actually draw the radius and the principal angle. So here I drew a radius of 5, so I'm going to call this 5, and then I still have to find, I'm going to create a right angle triangle here. And because I know it's quadrant 3 because it's from 240, 240 is 180 plus a little extra, and we can establish extras to 60 degrees. So right now I can actually use SOHCAHTOA to solve for this triangle in this quadrant 3. So we're going to call this x and this is y. And using SOHCAHTOA, I know that based on this angle here, 60, so I know that this piece is my OA, so this is opposite over hypotenuse. Hypotenuse is 5 in this case, so sine 60 is equals to y over 5. And to find the x, I'm going to be using adjacent and hypotenuse, which is cos. Cos 60 degrees, my reference angle, is equals to x over 5. And I'm going to just sort of rearrange. In this case, y is going to be 5 sine 60, and this is going to be 5 cos 60. And going over here, I go back to my numbers here, sine 60, it'll take some time. I'm not going to explain it in this video. It's in previous video. Is going to be root 3 over 2. X is going to be 5, in this case cos 60 is going to be 1 over 2, and we end up getting, let's put them in order, 5 over 2 because x comes first, and then y, which is 5 root 3 over 2. And you're wondering, yes, the digits look the same, but why are my signs different? And when you do the diagram method, you have to actually look at your diagram to see where the x and y are. You need to sort of like look at the location. In this case, x and y are in quadrant 3, they're both negative. So now we have the same answer. So we had a point on the circle. Let's actually sketch it out. When in doubt, sketch it out. So negative 6 and 8 is somewhere in quadrant 2. So here's negative 6. I'm going to draw the dot there. I'm going to draw the arm, the terminal arm. Let's label this as negative 6 and then positive 8. So I put up here, positive 8. And the question says to solve for the trig ratios. So trig ratios means the following. Let's set the question up. Sine cos theta, tan theta, cosecant theta, secant theta, and cotan theta. And ratios means to compare the sides. So opposite adjacent, whatever the sides we're looking at depending on the trig ratio. So you're wondering, well, where is this triangle? Well, the triangle we had before in quadrant 2 is going to look like this. Remember? The triangle that we make has to be made with the x-axis. So now we have our triangle. Now, miss, what's the principal angle? Well, the principal angle is always from the initial arm to here. This is your principal angle. But this triangle here will determine the triangle in quadrant 2. So let's right angle triangle. So that means we know this is negative 6 here, and this is going to be 8. Now the question is, what piece are we missing? We're missing the hypotenuse, or we'll call it the radius of the circle. How are you going to find the radius of the circle or the hypotenuse? Pythagorean theorem, so we're going to do h squared is equals to 8 squared plus negative 6 squared. And you do all this work, you end up getting 10 at the end. So I'm going to just skip some steps. So this is going to be 8, it's going to be 10. So now you go back to your first one, sine theta. Well, sine theta is what? Opposite over hypotenuse. So you go to your triangle, and that becomes 8 over 10. And you can reduce it 4 over 5. Now cosecant is the reciprocal, so we're going to just take the flip of this. Now cosecant is what? Adjacent. So adjacent over hypotenuse. Now hypotenuse is always positive. The radius is always positive. But in this case, what's my adjacent? My adjacent is this way. But you notice here the adjacent is 6, but it's a negative 6. Negative 6. And therefore becomes negative 5. And then therefore secant, which is the inverse, becomes negative 5 over 3. Tan is opposite over adjacent. So we're going to look for the opposite of the triangle, which is 8 over negative 6, and therefore the cotangent is negative 6 over 8. It doesn't really matter where the negative goes, top or bottom or in the middle. You can reduce it afterwards. So there is another alternative solution to do this. Sometimes some people like to use this equation here. I did say in the previous slide that xy, a point on any circle, can be represented using this. Is that correct? So in our case, do we know what xy is? Yeah, we do know. It's negative 6 over 8 right up here. That is a point. So we're going to actually do this. So we have negative 9, which is r cos theta and r sine theta. But the question right now is, what is r? We don't know what r is. Well, we do know because we actually can calculate this. So remember, we're going to use in this diagram here, we can still calculate the radius. So the diagram does address the hypotenuse or the radius here. So the radius is here. We're using Pythagorean theorem, which is we got the end 10. So that means negative 6 over 8 is equals to 10 cos theta and r sine, so 10 sine theta, all right? So remember what we said before? This x here refers to 10. In other words, I'm going to break this up and make negative 6 is equals to 10. I'm going to separate it into the x. I'm going to separate the y, which is 10 sine theta, and then I'm going to solve for the cos, because cos is what I want. I want to have the trig ratios. I just divide everything by 10. I get negative 6 over 10 and cos theta. In this case, 8 over 10, which is sine theta. And once we have cos and sine, we can actually figure out the reciprocal in this case. The reciprocal is cosecant theta is 10 over 8. You can reduce the fraction later on. The reciprocal of cosine is going to be secant theta, which is negative 10 over 6. Well, the next thing is, Miss, how are you going to figure out tan? Well, back a long time ago in previous videos, there was something called trig identities, where I mentioned that tan is the same thing as y over x, or we can call y is sine theta over cos theta. So if I wanted to find tan theta, I just have to take what I got for sine theta, the ratio, which in this case is going to be 8 over 10, and divide it by cos, which in my case is going to be negative 6 over 10. If I do some division work, I end up getting 8 over negative 6, or negative 4 over 3, which actually matches the same answer for the previous way. And then cotangent would just be the reciprocal of that. So there are several ways. It's just you have to pick the one that suits you best.